In this video, we will learn how to use realloc function in our C programs for dynamic memory allocation. So realloc is yet another built-in function that you need to call, and it is defined already for you in the stdlib.h library. And it is used to reallocate. As the name suggests, means it is used to change something, that is the size of the memory block. Means already some memory you have reserved in the heap area and you want to make some change to that allocated memory. And the change will be in the size of that block which you have reserved. Maybe you want to extend that block, or maybe you want to reduce that block. Okay, maybe you want to increase the size of that block, or maybe you want to reduce the size of that block without losing the data which is stored in that block. Okay, so already you have used dynamic memory allocation by malloc or calloc, and then you want to change the size of that block which you have reserved, maybe increase the size or decrease the size using realloc. And you do not want to lose the data which is already present in that block which you may have stored. So the syntax of realloc function is this one. You have to call using the name realloc, and the two parameters need to be passed. One is the previous name of the pointer which you have used. For example, if you have written int ptr, int asterisk ptr is equal to int asterisk malloc, and maybe you have reserved the memory for a single integer. So I have written size of int. So ptr is the pointer variable which you have used. That same name of the pointer ptr you must mention over here in case of realloc as the first parameter, and you want to suppose increase the size. That means you want a new size. So that new size is the second parameter. So for example, ptr is the previously used pointer for allocation, and size or new size is the new size that you want to increase or decrease it to. And here also, if it is not possible to increase or decrease the size, or if memory is limited in the heap or not available, this realloc function will return the null value. So see this example now. Int asterisk ptr is equal to int asterisk malloc 5 into size of int. Means here you want to store 5 bytes. Okay, 5 bytes you want to reserve. Sorry, you want to have 5 times 4 bytes. Means what? Size of int is how much? 4 bytes, and you want to store 5 integers. So 5 into size of int. So it will be total 5 into 4, that is you will be able to reserve 20 bytes in total. So suppose this is the block that has got reserved of size 20 bytes, and ptr will hold the address, starting address of this block of 20 bytes. Now if I want to change the size, okay, this is of 20 bytes, means I'm capable to store how many integers? 5 integers. For example, 2, 3, 7, 10, and 1. So I've stored 5 integers in this block of 20 bytes. Each integer occupies 4 bytes. Now I want to change the size, means I want to reallocate some memory. Reallocation may be either increase or decrease of this block size. So what I'll pass? Previous pointer which I've used, its name ptr. Then I want to change the size. Instead of the size for 5 integers, I want to have the size for 10 integers. So 10 into size of int. So what will happen? The size of the block will increase from 20 bytes to 40 bytes. Okay, 10 into 4 means 40 bytes. So now you have reserved space so that you can store in total 10 integers. Okay. Now the size of PTR has changed from 20 to 40 bytes dynamically. So here what we have done, we used PTR as the pointer variable, and then for reallocation we use the same PTR. Okay, you may use the same PTR or you may use some other pointer. Maybe this is PTR1 in the first case where you used malloc, and maybe next time you're using PTR2. That is also possible. For that you'll have to write int asterisk PTR2 if you're using a new pointer variable. Okay, that means previous pointer, suppose it is PTR1, your new pointer can be another thing, that is PTR2. Or if you don't want to use again and again different pointers, initially you use PTR, and for reallocation also the first parameter, that is the previous pointer that you've used, is PTR, and you're using the same PTR, that means the same pointer variable, for reallocation. Okay, now we'll see that whether this block, it will be the same block which is extended, or whether a new block will be created. Means, for example, if you have a block of 20 bytes, will the same block be extended so that I have space of another 20 bytes to have total of 40 bytes, or will I have a new block completely for 40 bytes? Okay, that we will see later on. Now let us see this example. Int asterisk PTR is equal to int asterisk malloc size of int. So first time you must use either malloc or calloc, and next time if you want to reallocate or change the size, you must use realloc. That's what has been done here. The new pointer is same, PTR only. Int asterisk for typecasting realloc. Previous pointer name is also PTR only, means same pointer we are using. 2 into size of int means initially I could store only one integer. That means 1 into 4. The block was of 4 bytes. And now I am able to store two integers, means 2 into 4, 2 into size of int. That means 8 bytes. So I have changed the size, I have increased the size. So this will allocate memory space of twice the integer size. Also, this function moves the contents of the old block to the new block. Means suppose the original block was able to store only the original block was able to store a single integer. But now if it is possible, means if the size is available in the heap for extending, then you can store the same block will get extended for one more space, so that you can store two integers in total. Okay, maybe this will happen if it is possible to extend, or if it is not possible to extend, if the memory is limited or you are towards the end or something, then what will happen, you will not extend the same block because it is not possible. You will create a new block. So in order to create a new block, again memory has to be allocated somewhere else. You will create the new block capable to store or hold two integers. Okay, so now the pointer will point to this new block and it will not point to the old block. Okay. And if new block we are using, then the old block content, suppose here the integer stored was 4, then this integer 4 will be brought to this first block of the newly allocated memory, and then you have another vacant space to store the second integer. Maybe you can store 6 or any other value. So old content will not be lost, but in some cases it may be lost. Can you think when? It will be lost if you, instead of increasing the size, you decrease the size. If the new size that you want to reallocate is smaller than the previous size or old size, then you may lose data. Okay, and newly allocated bytes are uninitialized. Means what? We'll see these 2 points in the program actually. So newly allocated bytes are uninitialized means, suppose initially you have this original block which has the integer 4, and you have increased the size using realloc. so that you can store two integer values. Okay, so the original value 4 will be brought in this new block, and this one more block that is remaining, I mean this second vacant space, it will have the default value as the garbage value. Okay, it will not be initialized to 0 by as if calloc. Okay, we are not using, it is not having the property of calloc to have the value as initialized to be 0 by default. Okay, by default the value will be a garbage value. If you try to print out the value at this particular position, it will be garbage value. Okay, so you can store your own value whichever you want, but by default it will be garbage. In calloc, if you do not store, by default that block will have the value 0. In malloc, if you do not store, by default that value will be garbage value. Okay, so malloc and realloc are same, only calloc will initialize by default to 0. Now suppose that is the meaning of the newly allocated bytes or newly allocated space will be uninitialized. Now suppose you use realloc before using malloc or calloc. That means first time, usually till now what we have seen, first you must use either malloc or you must use calloc, and then the next step will be increasing or decreasing the space using realloc. But suppose you don't do step 1, you directly do step 2, means directly you're using realloc. So what will happen in that case is realloc will behave like malloc. Okay, this is an important point to note. Realloc will behave like malloc. So let us see a program corresponding to this characteristic. So I've included stdlib.h, and in this case I've not included stdio.h. Why, can you guess? See, the program is this one, because I'm not using scanf or printf, right? So no need to include stdio.h. Sorry, here I'm using it, so you'll have to include it. Suppose you don't have scanf or printf, then you will have to ignore this header file stdio.h. But here I'm using it, so I have included it. So now in the main function, what we have done, we have declared a pointer to a character. Means this time in the memory we want to store characters and not integers. And then it is a good practice to write equal to null, right? Before you point it to some location, it is good habit to write it as null. I've told you the reason already. Since pointer is null, realloc will act as malloc function. Okay, so null means what? It is not pointing to any location. So you're going to reallocate, or you're going to assign memory now. That is the meaning of realloc here. There is no memory allocated, so you're going to allocate by realloc. Okay, null means it is not pointing to any location. So now you will realloc. So the previous pointer is ptr, and you want to store 10 characters, suppose. So 10, or you can write 10 into size of char. Now size of char is 1 byte only, right? That means 10 into 1 is 10 only. So even if you don't write size of char, it is okay, because 10 into 1 is 10, and 10, if you write it, means 10 only. So either write 10 into size of char, but since char occupies 1 byte, you can write directly 10. Okay. Now if ptr is not equal to null, means if it is not equal to null means allocation of memory was successful. If memory allocation was successful, ptr will not be null. If ptr is not null, this message will not get printed and you will terminate the program. But if ptr is null, means reallocation or calling this realloc function was a failure, it was not successful, memory was not able to get reserved, then you will display the message memory created unsuccessfully. But if this ptr not equal to null, means memory allocation was successful, then you will execute it. Okay, so if ptr is equal to null, then memory created unsuccessfully. But if ptr is not equal to null, memory is created successfully. Okay, you can run this program and check it out. Now let us continue. If the given size is bigger, means the new size is nothing but you're extending the original size, then it will check whether it is possible to expand. Okay, if there is available memory and so on. If it is possible, then it will resize the same block. Okay, it will resize. So originally you have 10 bytes. If you want to increase it to store 20 bytes, then it will increase the size by 10 bytes. So that 10 plus 10 total you can store data for 20 bytes. Okay, it will resize the same block if it is possible. Otherwise, if it is not possible, if there is limited memory or at that position there is some other data already stored, then what will happen? Realloc will create a new block of the new size, maybe larger size or maybe reduce size. So if it is of larger size and it is not possible to resize, then originally suppose you have a block for 10 bytes, then you want to increase it to 20 bytes, then it will have a new block which is away from this block. Okay, and it will have 20 byte memory. So this original block and this new block are not related to each other. So in this case, what will happen? Whatever data you have stored in this original block, suppose you have stored an integer 2, then it will be copied first to this new block, and then the remaining blocks you can store some data in it. Okay. So if it is possible, it will resize. Otherwise, it will create a new block in some different section of the heap itself. And what will happen to the old block? After copying the data of the old block to the new block, it will deallocate the memory for the old block, right? Because you have copied the data from the old block to the new block, so you don't need the old block now. So you will deallocate it. It will happen. Now, for example, assume we have allocated memory for 2 integers. Now we want to increase the size for 4 integers. If it is unable to expand the size, then what will happen? See this pictorial representation. Initially, old block can store 2 integers, but now we are at the end of the heap or something like that, so it is not possible to extend further down. Then what will happen? New block somewhere where there is space available in the heap will be created for storing 4 integers, and this old data, that is 1 and 2, the integer will be copied, and then you can store the different integers in the vacant space of the new bigger block. Now let us see a programming example. So in this case, we are going to store the floating point values for a change. So initially I'm using calloc, right? Either calloc or malloc you can use. And I want to store 3 floating point values. So I've used it by this syntax. Now at the 0th position, I want to store this float value. Then at the first position, I want to store this value. Means what? For example, I want to store suppose I want to store 3 floating point values. Then what I'm doing, I have the block in which I can store 3 floating point values. So if I'm writing P1 of 0, and suppose I've used the pointer P1, then P1 of 0 means this particular section. If I say P1 of 1, means this particular section. If I say P1 of 2, means this particular section of the block. So at P1 of 0, I am storing 40.18. At P1 of 1, I want to store 25.43. And at P1 of 2, I have not stored anything as of now. So then I want to currently print out that what values are there in my memory block. So originally, see here, I'm going to store, I have reserved space to store 3 floating point values. So I'll run my loop for 3 times. So 0, 1, 2 are the values of I for which the for loop will run. And then I'm going to print out that P1 of 0, P1 of 1, P1 of 2 is whatever the value. Okay, so I'll be able to print what? For this example, what will get printed at the output? Let us understand. So at the output, firstly, P1 of 0 will get printed. That is the value 40.18. And we know that for float, after the decimal point, you have 6 digits. So 0, 0, 0, 0. So this will get printed. 6 digits after the decimal point is by default whenever you print a floating point value. And you know how to change it. If I print out P1 of 1, what will get printed? 25.43. 43 0 0 0 0. And if I go to print out p1 of 2, and I've used which function for allocation? I've used calloc, right? So by calloc, what is the characteristic? If there is any vacant space in which you have not stored anything, then by default that space is initialized, or 0 is stored in that place. That location is initialized to 0 value. So then it will print out 0.000000. Okay, so this will be the output for running this particular for loop. Next, I want to change the size, I want to increase the size, I want to expand the size. So what I'll do, in this case, the pointer was p1. Now I'm using pointer p2. Okay, you can use different pointers, no problem. And then I want to store float, so typecasting and realloc function. Previous pointer was p1. And now I want to change the size from 3 floating point values to, I want to store 4 floating point values. Okay, 4 into size of float. This is similar to how you do it with malloc. And then what we have done is we have increased the size to store 4 floating point values. So what will happen? Suppose it is able to resize, then how it will do it? It will extend this only. And originally I can store 3 floating point values. I want to store 4. So one more section will be added. And this you can refer by index number 3. Okay. And now P2 is the pointer for this particular block, resized block. So you have to, this will change to P2 is pointing to this block now. So P2 of 0, P2 of 1, P2 of 2, and P2 of 3 you have to use to access the blocks, the sections within the blocks. Okay, so if it is possible to resize, it will happen like this. Or if not possible to resize, then what will happen? Somewhere else within the heap only, another block to store 4 bytes, 4 values. Okay, so P2 will point to this, and then the original data will be copied. So 40.18 will come here, 25.43 will come here. And since you have not stored anything, there is 0 over here, so 0 will come here. And in the remaining block, nothing is there, so garbage value will be there over here by realloc. Okay. Now what I'm doing, I want to store something at the index number 2 and at the index number 3, because previously I've stored only 2 values at index 0 and index 1. Now I want to store at index 2 and index 3. So it will get stored here. Now if I want to rewrite some value, means originally there is 0 over here, that will get replaced with the new value which I want to write. The new value is 12.44. So 12.44 will come here, will get stored in the memory. And at P2 of, so this is P2 of 0, this is P2 of 1, this is P2 of 2, and this is P2 of 3. At P2 of 3, which value is stored as per my program? 30.32. So here instead of garbage, 30.32 will get stored. Okay. So I hope you understood this. And then I'll run my for loop for 4 times. And I'll print out the values one by one. So here what will be the output? What is stored in memory? First you will get 40.18, then 25.43, then 12.45, and 30.32. All these 4 values will get displayed. Now next is size reduction. So currently I can store 4 floating point values, means 4 into 4, 16 bytes. Now size reduction is what I'm doing. Instead of increasing the size, so first time the size was 3 floating point values. Then I change it to store 4 floating point values. Now I'm changing it to 1 floating point value. So what will happen? Resizing. Resizing means what will happen is, this is the size for storing 4 bytes, 4 values. Now resizing to store only 1 floating point value. That means only a single section will be available. and these remaining will not be considered. Okay, resizing, in this case reduction of the size. So here what is happening, loss of data, as I mentioned, if you increase the size using realloc, the previous data will be retained. But if you reduce the size, it is possible that the previous data will be lost. So this time only one value I am able to store. So I'll run the for loop only once for I is equal to 0. And then I will print out the value. And then as per the good practice, you must free the allocated memory by calling this free function. Okay. So when I run this program in, for this time I'll run it in online compiler. So I'll run this program. It is running, compiling. So originally we had stored two values, as you can see here, 40.18 and 25.43, and the remaining was 0. Why? Because we had used calloc. Just a minute. Okay, three spaces we had reserved, but I stored only two values. So by calloc, the remaining which are not initialized are by default 0. Now after expanding the size, what happened? I stored another two values. So original data was not lost and the remaining new two values were able to get stored. Now after size reduction, only one value will be able to print out. Okay, these remaining three values, okay, they'll be there in the memory, but they will not be a part of that block. Okay, because size has been reduced of that block. Now just a moment. See here another application of free function. I mean the example of free function. What was happening is I freed the memory which was allocated for that storing the data. I freed it. And after that, if I go to access the value, okay, after freeing, if I try to print out the value in the block, then what will happen? Since you have freed the memory, it will print out the value as 0. So it was the value 40.18 that was stored in that block. But after freeing, the value is 0. Okay, so free will deallocate the memory. It is like null, you can say. It will become null. So I hope you have understood realloc function and the different characteristics of this function. Basically, it is used to change the original size of the memory, maybe increase the size or decrease the size. Okay. Same thing, reallocation, you can try it out for arrays also. We have used malloc and calloc for storing a collection of data or multiple elements. Similar, it is like storing an array of elements, right? A list of elements. So in case you want to increase or decrease the number of elements in your list, that time also you can use realloc. Okay. If you have any doubt, you can contact me. Thank you for watching this video.